Question 26. The preparation of a meal requires the completion of all 10 activities A to J. The network diagram shows the activities and their completion times in minutes. Part A. What is the minimum time needed to prepare the meal? So let's go through and do the forward scanning exercise here. So starting from 0, so that's at the start, the 0-minute mark. Activity A takes 14 minutes. Activity B takes 6 minutes, but activity C takes 8 minutes. With forward scanning, we take the higher of the two numbers. So that vertex is reached at the 8-minute mark. So activity D takes 12 minutes plus 8, okay, and that takes us to the 20-minute mark. Activity E takes 6 minutes. From the 20-minute mark, that takes us to the 26-minute mark. We have a 14 here already, but we take the higher of the two numbers, or the 2 times. So I'm going to put 26 here instead. Activity F takes 10 minutes. From the 26-minute mark, that takes us to the 36-minute mark. Activity G takes 9 minutes. From the 20-minute mark, that takes us to the 29-minute mark there. But we can reach this vertex through activity H as well. So 36 plus 8, that gives us 44. Well, we have a 29 there. 44 is clearly the larger number. So we'll put 44 here instead. Now, to get to the finish, we can either go through, in fact, activity J or activity I. In fact, both have to be completed, but comparing the 2 times, 36 plus 7, that takes us to the 43-minute mark. Okay, but we're still not complete yet until activity I is completed. 44 plus 2 is 46, so that's the higher of the two numbers. So the minimum time needed to prepare the meal is 46 minutes. Now part B lists the activities which make up the critical path for this network. So this is where we do the backward scanning. So backward scanning, just think of it as forward scanning but totally in reverse. Instead of taking the larger of two numbers or multiple numbers, we take the smallest this time. But we're going against the flow of the arrows there, or against the direction of the arrows. So starting at the 46-minute mark, going through activity I, or back through activity I, 46 minus 2, that gives us 44. Okay. Now 46 minus 7 gives us 39. Okay. However, to get to this vertex here, we can go back through activity H. So 44 minus 8 gives us 36. So we rub out the 39, or cross it out, and we're going to put 36 here instead. Now, going back through activity F, 36 minus 10, that takes us back to the 26-minute mark. Okay. Now, 26 minus 6 gives us 20. However, we can get to this vertex via G, so 44 minus 9 is 35. 35 is higher than 20, so I'm just going to leave the 20 as it is there. Remember, with backward scanning, if there's a multiple path or a multiple way to get to a vertex, you take the lower or the lowest of the times that you've found. 20 minus 12 is 8, so that's fine. So we can leave that there because there's only one way to get to this vertex. And then back to the start, 8 minus 8, that gives us 0. We also have 26 minus the time for activity A, 26 minus 14, that gives us 12, but 0 is clearly less than 12. So again, we take the lower of the two numbers. So the activities which make up the critical path for this network, okay, we've got this one here, C. Okay, in fact, I could highlight this and it might make it just easier to see. So we've got that one there. Basically, you're looking for the earliest start time or the latest start time where they're identical. So the two numbers are in fact the same. So activity D through activity E, okay, through activity F, through activity H, and then through activity I. Okay. So it's C, D, E, F, H, and I. Okay. Finally, part C. Okay. So complete the table below showing the earliest start time and float time for activities A and G. So the earliest start time, I think that's fairly simple to fill out. So why don't we do that first? So the earliest we can start activity A is at the 0 minute mark. So why don't we do that? And just write that down. So 0 minutes. Activity G, the earliest it can start is at the 20-minute mark. Okay. Now, the float time, the way I work it out, and there's multiple ways of doing it, but I take the latest start time minus the activity time of the particular activity we're looking at. So the latest start time of the activity following the activity that we want. So I take this number here, so the bottom number after A, minus the activity time of A, then minus the earliest start time of A. So 26 minus 14 minus 0 is equal to 12 minutes. Okay, so I've just written it there. 26 minus 14 minus 0 is 12. And for activity G, okay, 44 minus 9 minus 20 will give us the float time for G. So 44 minus 9 minus 20, okay, and we'll get 15. Okay, and that's that.